Today we're going to review the elimination method. Warm up. Can you identify which method would probably be the fastest to solve each system? Put an S, G, or E for substitution, elimination, or graphing. So if you take a look at A right here, again, we're trying to see where these two lines cross each other. And since Y is by itself in one of the equations, then substitution would be the fastest method here. You could graph it. You could get Y by itself and graph it. You could also do elimination if you get X and Y on the same side. But for me, just looking at it, if one letter is by itself, plugging in is a little bit faster for me, and so I would say substitution. Again, there's not really a right or wrong answer for these ones, just depending how fast you are with solving. For B, since X and Y are on the same side, I say they're stacked, then for me, elimination, I guess I could have just put the E, elimination is the fastest method. And the reason is, in order to use any of the other methods, we have to get X or Y by itself. So to graph it, you'd have to get Y by itself. To use elimination, you would have to get X by itself. So again, this is for me. Elimination would be the fastest. You might find one of the other methods to be faster. You just have to get at least one of the variables by itself to use any of the other methods. All right, let's take a look at this one. This one I would say graphing because they're both y equals. If I had Desmos, I could just type this in. Again, because they're both y equals, so I would say G or graphing. And then for our last one, again, for me, substitution would be slightly faster because X is by itself. If I want to graph it, I have to get Y by itself. If I want to do elimination, I have to get X and Y on the same side. So I would say substitution for letter D. So if you watched the video yesterday, we went over the elimination method. And so today we're going to do more review of that elimination method. Just do a bunch of examples so you kind of get the hang of it. So elimination is for finding the intersection of two lines, a system of equations. Here are the steps. You want to stack the equations with corresponding variables lined up. So put the x's on top of the x's, the y's on top of the y's. You want to manipulate the equations, so you eliminate or drop out one of the variables. You'll add the equations together, solve for your first variable, plug in and solve for your second. So again, when you use the elimination method is when your variables are stacked. So when x and y are stacked. What I mean by that is they're on the same side of the equation for both equations. So when x and y are stacked. So let's take a look at an example of elimination. All right, so this one right here, it would say solve, find the point of intersection. I guess it was example one. And since x and y are on the same side, I would choose elimination to solve. If you wanted to use substitution, you have to get x by itself or y by itself. If you wanted to graph it, you'd have to get y by itself for both. So in this one right here, I chose elimination, and so I'm going to have to choose a variable to get rid of. We can get rid of either the x or the y. It actually doesn't matter. To get rid of them, you have to make a match, and one has to be positive and one has to be negative. So for this one, just looking at it, I would choose to get rid of the x. If I choose to get rid of the x, again, you have to make them match. One should be positive, one should be negative. And so I want to turn the bottom equation into a 3x instead of an x. So first step, I'm going to multiply everything on the bottom by 3. And I'm just going to rewrite the equations right here. So the top one I didn't change. Negative 3x plus 5y equals 6. And the bottom one, I'm going to multiply everything by 3. So I'll get 3x minus 3y equals 18. So again, the first step is to pick a variable to cancel, and the second step is to manipulate your equations so that one of your variables matches the other one, except one is positive and one is negative. So you might need to multiply one of the equations like I did here. You might have to multiply both equations by something. You might not have to multiply either equation by anything, and we saw that yesterday. All right, so now we're going to add them together. So here we go. We'll add them together. You eliminate the one that you chose to eliminate, otherwise you did it wrong. So here the x's are gone. Now we have 5y minus 3y, that is 2y. We're going to add together 6 and 18, and we'll get 24. Next step, we'll solve for that variable. So I'm going to get y equals 12. And again, I'm looking for the point of intersection, and I'm halfway done. I know the y value. When they cross where y equals 12. So then the next step is I'm going to choose one equation, and I'm going to plug in y and solve for x. And you can plug into either equation. It doesn't matter. Oftentimes, one is a little bit easier or faster to plug into. And so just looking at it, I'm going to pick the second equation because there's less numbers there. So I'm going to plug in the 12 for y. So I'm going to have x minus 12 equals 6, and then I'm going to solve. So we'll add 12 to each side, and we'll get x equals 18. So I know that if I were to graph these 2 points, they would cross, and they would cross at the point 18, 12. So there's 1 point of intersection if I were to graph those. How can we check our answer? We can plug into the equation that we didn't use. So that equation was the top one, it was negative 3x plus 5y equals 6. I'm going to plug in for x and y and see what I get. So negative 3 times 18 plus 5 times 12. I'm going to see, does that equal 6 right here? So I'm going to pull up my calculator here and I'll just type it in. It'll be a minute till I pop that up. All right, sorry, it takes a second to pop that up. Okay, so I'm just going to type in my equation here. Once it loads. Close. Okay, so I'm just going to type in, and it was negative 3 times 18 plus 5 times 12, and I should get 6, and I do. So you can check your answer by just making sure that when you plug in, both sides are equal. So all these you can self-check, and yes, we get 6 equals 6, so it's right. So again, what does this solution mean? It means that the 2 lines, they cross at the point 18, 12. Okay, so let's take a look at our next example. Example 2, I'm going to zoom in. Again, the variables are stacked, x and y, so I'm going to choose one to get rid of, and it doesn't matter which one I choose. This time I'm going to choose y. So what I want to do is I want to make them match, 2 and 4, and they both go into 4. So I'm going to make them both into 4s, and then add them together. So in this one, I just have to multiply the top equation by 2, so that I can get the 2y to be a 4y, and I'll rewrite it. So we have 6x plus 4y equals 12. My bottom equation, I don't need to change because I already have a 4y, a minus 4y. So again, in elimination, you have to pick one. Oh, I forgot to multiply this 12 by 2. So let me redo that here. This 2 times 12, I should have put 24 here. So again, the first step is to pick one to get rid of. And then you have to make them match, but one should be positive, one should be negative. So if you notice, when I add the y's together, they should eliminate, and they do. We're going to add the rest together, but notice what happens, 6x minus 6x is 0, and 24 minus 24 is 0. So in this situation, we get 0 equals 0. And that is always true. 0 equals 0 is always true. So what happens is, if we were to graph these would be the same line. Okay, so same line. If you get 0 equals 0, it means the same line, and it means there's infinite answers because I'm asking for where do the lines cross, and they cross everywhere. So I want to show you what this looks like. What I'm going to do is I'm going to solve each equation for y, and I'm going to graph them and show you that it's the same line when you get 0 equals 0. So first I'll take this top equation. I'm going to get y by itself, or solve for y. I'm going to subtract 3x from each side. I'm going to get 2y equals 12 minus 3x. I'm going to divide everything by 2 to get rid of this 2 right here. And so my first equation is y equals 6 minus 3 over 2x. So there's my first equation. I'll take my second equation, and that is negative 6x minus 4y equals negative 24. And again, I'm going to get y by itself. So I'm going to add 6x to each side. I'll get negative 4y equals negative 24 plus 6x. I'm going to divide everything by negative 4. A negative divided by negative is a positive, so I'll get y equals 6 minus, and if I reduce the fraction, 6 over negative 4 is the same as 3 over 2. And notice, we get the same line right here. So if we were to graph them, they would be overlapping, and there'd be infinite solutions. So if you get everything to cancel, if you get 0 equals 0, which will happen on today's assignment, it means that it's the same line and there's infinite answers or infinite solutions. Okay, let's take a look at example 3 right here. And again, let's use elimination. Let's pick one to get rid of. I'm going to get rid of the x's because they're a little bit smaller. What do 4 and 3 both go into? And they both go into 12. So I want to turn those both into 12, but one should be positive and one should be negative. So what do I multiply 4x by to make it a 12? That would be 3. What do I multiply negative 3x by to make it a negative 12x? And that would be 4. All right, so again, I want to make them match. And here I'm going to have to multiply both equations by something to make a match. All right, so let's multiply this out. We get 12x minus 24y equals 15. There's the top equation. In the bottom, we'll get negative 12x minus 24y, plus 24y equals 44. So again, all I'm doing is distributing and multiplying. All right, next up, add them together. We chose to eliminate the x's, and they do eliminate. 12x minus 12x is 0. But then what happens for this one is the y's also cancel, so we get 0 equals 59. And 0 never equals 59, so what does this solution mean? Again, I'm going to solve each equation for y, so I showed you that, but without showing you all the steps, here's the answer. So if I solve each one for y, here are the equations. So it's the same equations, just solve for y. I'm going to type them into Desmos so you can see what that looks like. Okay, so the first equation, if we type that in, we get y equals negative 5a and plus 1/2 x. Okay, so there's that line. Let's graph the other one and see what that looks like. And again, we're looking for where do the lines cross. That's the solution. 11/6 plus 1/2 x. And as you can see, both equations have the same slope, so they're parallel, but they have different y-intercepts. And parallel lines never cross. So if I ask you to find the solution and you get 0 is equal to a number, which 0 is never equal to a number, you're going to say there's no solution. Why is there no solution? The lines never cross. Okay, so we'll do a quick review. We've done elimination now 3 times, and we've gotten 3 different results. Oops. In the first, and this is what you guys saw more of yesterday, in the first problem, you can solve for x and y, and if you get a coordinate, the lines cross at one point. So here is the most common thing that will happen when you solve a system is that the lines cross and you get one coordinate. There's one solution here. All right, the next thing that can happen that we saw is you can get 0 equals 0. And this is the same line. So there's infinite solutions because there's infinite points on the graph where the lines cross. And then our last situation is you can get 0 equals a number that's not 0, and then we would say there's no solution because we have parallel lines and the lines never cross. So the goal today is to really practice that elimination, but just know that when you do any of these solving the systems, you might get 3 different things that happen. They can cross at one point, which is the most common. It might be the same line, which means infinite solutions. And it might be parallel lines, which mean no solution. So today your goal is to review by graphing. So there's a graph one here first, solve by substitution, and then there's some solve by elimination. And you'll get 2 where you get an answer, and you'll get 2 where you get different things, not silly, but different things happening. You can either get parallel lines or you can get the same line, infinite solutions. And then I'll have you look through different work and see, can you figure out what's happening in each of these steps. So your assignment is the next 2 pages, 22 and 23 for tomorrow.